In this video, we're going to work through practice 2, or problem practice 2, which is sine squared x plus 1, and we are looking for x values between 0 and 4 pi. So the first thing we need to work on in this and think about is what this notation is actually telling us. Well, this notation is just another way of saying we're taking the sine of our x value and this is becoming a quantity squared. So if we rewrite it in another form, we can see how to solve this now. So if I want to undo the squared, I want to isolate this trig function sine x to be the only thing on the left side. I need to square root the left side, and that is the inverse of squaring. But what we do to one side, we do to the other, so we square root 1, and in doing so, we pick up two solutions, plus or minus here. So what we're left with is sine of our x value that we're looking for, or what values do we take the sine of to produce positive or negative 1. And to do this, let's work through the unit circle. We'll look at 1 revolution, which is what is represented in this image to the right, and then we'll just add 2 pi to our answers to get that 4 pi in our domain. So we're looking for sine, or y values, that in radians, because this is in radians, y values that are 1/2, or what values have ordered pairs with a y value of 1/2. So, or of 1 actually in this case. I don't know why I was thinking 1/2. I was looking at that. So we want ordered pairs on the unit circle that have y values of 1 or negative 1. So a y value of 1 would be pi halves. And then another y value of negative 1 would be 3 pi halves. So if we're thinking about one of our domains, we just went 1 revolution. So for x values between 0 and 2 pi radians, the solutions to this equation are x equals pi halves and 3 pi halves. Now as we go through our second revolution now, we're just going to take these answers and we're going to add 2 pi to them. Well, since we're working in pi halves, 2 pi in terms of halves is actually equivalent to 4 pi halves. So we're going to add 4 pi to our numerators here. So when we do that with pi halves, we have 5 pi halves. And then similarly, we do it with 3 pi, well, we have 7 pi halves. And if we think about this, 7 pi halves is actually really close to 8 pi over 2, which puts us at 4 pi as our bound. So we are done with this problem. There we have it. This problem was a little different in that what was happening to solve for it. I hope this helped.